Hello and welcome. I'm Bill Wake. We're working on types in our basic interpreter today. Let's see, there's a little bit of theory to it. Types are basically a recursive construct. So we have an integer type that's for line numbers only. I don't know if we even need to represent it. We have strings, we have floats, and then you can have an array of types. And I think we want the number of dimensions to be the integer there. And you can have functions that take argument types and go map to, result types. Now we left off here. Okay, yeah, so test assigned string to number fails. So if you were doing type checking, you would realize that $B is a string and A is a number, and you can't really make that assignment. Hey, Rick, nice to see you again. You can't legally make that assignment. It doesn't make sense, at least in basic. I mean, there are languages that will, try and convert the string to a numeral, and I don't know. I never keep track with JavaScript these days, but a lot of interesting conversions can happen when you try and make everything legal. But I think we started laying out the notion of types, and I think I'm going to do a rename on this. I'm gonna use that little backtick construct. There we go. Quote type quote. I hope that works. Okay, I just got tired of saying types when it's really type. Okay, and so we got the representation here. Really, this should probably be int and type, as I mentioned before. But we don't handle those anyway right now, so I'm just going to start here. Okay, and we don't really express the type of an expression yet. So I think maybe that's the thing to do is let's add something to expression so you can ask it, hey, here's an expression, what's its type? Okay, that's a very good question. All right, so I don't think we have an expression. We don't have any expression tests. This is still in the parsing mode. Well, it's a little deeper than parsing. It's kind of a semantic analysis, but we'll get by. Okay, tests. Expression make. Okay. New file. And I'll just copy it from another test, so it's okay. Expression tests. Okay, and this is expression. Let's see. So test number has type number. All right. So we're going to we'll create a number and give it a floating point number, and then assert that its type is float. We'll do that. Okay, so let number equals number of 37. I'll even throw that in. Okay, and then assert equal number dot type should be dot float. And I don't know if I can use that word. Equatable has no member float. Type is equatable. And he's not figuring that out either. Okay, so this is parse.number. We don't have a method called type, so that should be confusing something. Parse has no member number. Oh, expression, sorry. This is the expression test. Equatable has no member float. That just seems weird. This says it's equatable. Case float. All right, well, let's get the type method and see if that helps anything. Function type returns a type. And I may be I may be courting trouble with keeping that name the same. I don't know. All right. Well, let's just return something wrong. String. Okay, are you going to work? Should fail with string instead of float. Okay. All right, string is not equal to float. Okay, so let's just do a switch here. Switch on, what do you say for this? Is it self? Okay, good. And we'll just work our way through. Variable. Okay, this should partly pass because we hard-coded. Oops. Expression has no member float. Oh, dot type. Okay, it passed because we said everything returns string, everything else returns string. All right, but we'll put the case in for variable. Okay. And now it's tricky. Our operator expressions. I mean, they can be strings. I can't remember if we get a plus operator that takes strings in BASIC. I don't know. I mean, so far, everything we do is numbers. Yeah, I think everything is numbers so far. So let's so this thing, let's do op1 dot minus with number 3. The type should be float. Okay. If you say minus 3, the type should be float. If you say plus 1, 2, type should be float. Oh. I really thought it should pick that up. Okay, and these will fail. Okay, so I think for now the default is float, and I'm not even going to call it default. I'm gonna be explicit here. Case op1. It just takes a token and an expression. Okay, token, expression. Okay. All right. You can tell it would be good to get the array stuff in, and it would be good to get the string stuff in, because the functions for strings. I don't remember if the basics use a plus for string addition. Maybe they don't. Maybe they don't even have the concept. I'm not sure. You can do it implicitly in print, but I don't think you can do it in general. All right. But anyway, we've got this expression type with everybody knows their type. Okay. The variable has its own type. Let's go back and see our test here. All right. This should still fail, but now we have the types. Okay. So let's go to our parser for assignment. Okay. Down a ways. Assign. Okay, left type equals type for name. I don't think we need that. Let's see what type 4 looks like. I think whoever defined the variable let's see, that's probably the lexer. Keywords and names. Okay. First handle variable. Okay. This digit. Oh, it really just knows the token. I don't know. Maybe it should know the type as well. I'm rushing in here and it's like, oh, I don't want to stop and think. And that's not good. Okay, so that's the parser test parser. Okay, so we get the type for the name. This is the variable token, right? But somewhere assign name to expression. Well, type for name is okay. Expression is more the interesting one. Okay, so instead of type for expression, let's do expr.type. And you can see why I want to let my expression do it. You know, it's the thing that knows all that stuff. Okay, and now I want to test the error. So this is the error. If left type not equal right type, throw parse error dot mismatch. Okay, so we go to the assignment. Left type was never used. Yes, it was. Okay. We get the type from the variable. We get the type from the expression. If they don't match, then that's the syntax error or the semantic error, really. And I think that's legit. And I think this will fail. Sorry, I meant succeed. It's like going to accuse myself of being an optimist, but yeah. So let's just say we got simple type checking. Assignment must have same type on LHS and RHS. Common abbreviations. Left-hand side and right-hand side. Sometimes you'll also hear L value and R value, where the L value is what you're assigning into. It's on the left, and the R value is what's being assigned. Okay, there's a lot of stuff in there. All right. Okay, so this is 22-12. Did I get that right on here? Yes, I did. Okay. And expression types. I don't think we've done everything there is to do yet. Well, no, we have not done everything there is to do, but I think we've done everything there is to do based on what we have so far. The type of an expression is string only if it's just a string variable. That's the only way right now. Okay. So we've enforced okay. That's a good thing. So I believe, well, we've kind of done this. We'll probably come back around, but we did put the type in and make that work. Yeah, I'm feeling like there's something not quite right here. Variable with a type. Where do we set this? Yeah, that's what I want to make sure about. The variable on the right-hand side is fine, but we don't have a variable on the left-hand side? This is the token variable because we're looking at the token. And require equals, okay, parser. Assign is name an expression. I don't think that's the right way to go. Because look where we're headed, right? We have name equals expression, but we're also going to have subscripts at some point here, not too far down. And so you'll say x sub 3 equals 42. This name field is not going to cut it. Now, the complexity may be, I mean, you can't do arbitrary expressions, right? It's only name followed by optional subscripts. But this is where that L value thing comes in. Like, what's a legitimate type on the left? And I think it should be that variable object, even like it is on the right. If I go down to factor, numeric factor, variable. Okay. We dig up the type for this variable here. Yeah, I think what I would like to do, I think this code belongs in the lexer, and that the type of a variable maybe belongs in the token, and then we'll just copy that out into our expression. But I think our left-hand side name is too limiting, and it puts it in, it's a different domain too, right? It's like the name, okay, let me go concretely here. Name here is just a string, so it's down in this text domain, whereas variable itself is a little higher concept. I don't mind the variable knowing that, but the assignment, like this one, that should be a variable, possibly followed by a subscript and so on, with a bunch of expressions inside, right? Because you could say x sub 3 times 2 equals 42. And the computation is perfectly fine in the subscript. All right. So I think this one is not enough. And I think as part of that, the token should be, I don't know. I hate to put the types in the tokens. Like, nothing else in token land builds in a type. So maybe it is the job of whatever's pulling out a variable to do that. In our case, there was a variable. I mean, this is legitimately, I mean, I think our assignment could take variable. Let's see what the consequences are if I change it. Okay, assign. This is, it's really going to be expression, isn't it? Ooh. I mean, the thing is, it's a restricted expression. Like right now, you can only have an expression that's a variable, but I can't just do variable as its own thing. Okay, yeah, let's do it and see. It's a little bit of a spike, but I'm pretty sure it's the right direction, so maybe it's not a spike. Some stuff should not build. Any assignments? All right. Okay, name. And we've got the type up here. Type 4. Yeah, that's legit. Okay. Well, I think what we want to do here, assign. Okay, sorry. We know, what are we seeing on assign? How do we get in here? Okay, we saw a variable, and that really is the only thing you can see there. I mean, it pretty much has to be a variable, or let, and then it's still a variable. So this variable, I'm going to say let variable equal variable. Can I do that? Oh, do I have to get the name? Okay. Variable subname. And maybe I don't have to if I really, let's see variable down here. It does take the name. Okay. So, all right. So we look at the token name, and I realize that's probably a little confusing that there's two different variables, one expression, one token. But it is what it is. Okay. If we look up the variable name, it has a type. Okay. So we can left type equals variable dot type. Okay. So we can get it out of there. And the left type carries on down here. That should be fine. Okay. So expression do assign cannot convert value of variable. Is this interpreter? Well, do assign is, let's deal with the parser first. Okay. Assign, well, we don't want to assign the name now. We want to assign the variable down here. Okay. Then the interpreter side, do assign, this is variable, just to be a little more, it's more than just a name. And do assign assign name of expression, and let me format this a little. Okay. Output name expression. Let's change this to variable. We know it's going to be a variable, but I think we're going to have to prove it. Let's change it to L value. We'll use that language of the left-hand side of an assignment. Okay. And then I think what we're going to have to do is we're going to make if case variable. Well, maybe I can do it up here. Guard case variable of let name let type equals L value. I think it's else. Else return improper L value. This should be a can't happen case, in the sense that we don't intend to ever let anything but a variable be on the L value for now. In future time, when we do subscripts, then that's not going to be true. And maybe with function definitions with def function, I don't know. All right, so we get the name. Now we can use the name and do that. So I think, did we get everybody? Oh, one more. Assign. Yeah. Immutable type. Yeah, we don't need that. We've already worked out all the types. I don't need that. They might complain that you aren't. No? Okay, good. Let's run tests. Parser tests. This should be a variable. Okay. And this one? Can't convert value type string. Build succeeded, but you have this error. That's really weird. All right, let's try this again. Okay. Oh, okay. Something went wrong. Interpreter test and parser test. Let's get the parser straightened out first. Assignment statement with number. Okay. If it's skip, we didn't assert the errors. Let's make sure this is there. Oh, and that one failed. Oh, check error. Assignment missing equal sign. Ooh. Okay, let's run that again. I'll just run the parser tests. Sounds like something else is going on. Okay, let's get up here. Skip, yeah, we don't care about that. This one. Assignment is missing equal sign. So I did something wrong in my parser. Variable consumes the token, so we don't need to do next token. Okay, and run them all. I'm hoping the interpreter was just messed up because of that. Yes, okay. All right, so what we've done is we've made assignment take a more complicated expression. And you can imagine, I mean, there definitely are languages that have more complicated things going on. Like some of them you can say, you know, do a swap with x comma y equals y comma x kind of thing. Multiple variables being assigned at the same time and stuff like that. Okay. Let's see. So the other thing I noticed, token, where's Lexer? I'm pretty sure we can use ranges on these. I think that should work. Okay. All right. Maybe this is the moment for strings. I'm dreading it a little bit because I know there's at least one other problem we're going to have from it. But okay. Yeah, I think it's time to do this. And then, I don't know, we have these, let's see, where's that summary page? Oh, there's some. Well, here's string functions. You can take a string as an argument. You can return a string. You can take a mixed string and integer or a couple of them. So those functions definitely need to manage their types. Yeah, I'll leave it at that. All right. Yeah, let's start strings. Okay, so my universal picture, we don't handle strings at all yet, so we have to deal with them in scanning and parsing and then interpretation. So we're gonna we haven't dealt with quotes at all, so let's do that. We'll need some Lexer tests. Okay. And then the other thing that's going on there with the Lexer, somewhere early on, yeah, notice this statement. Basically, we were normalizing the statement is probably the way I would say it. Any occurrences of space, we replace them with an empty string. So we squeezed out all the spaces because basic, you could say, well, you could say, instead of print, you could say PR space int, and you could say space 4 space 2, and it would print 42. Okay, it's yeah, there's definitely something there. This normalizing. So if you do that with your strings, right, and you print hello world, you're gonna knock that out. So let's make sure we cover that case. Okay, do we have a token for it? We have integers, numbers, and variables, but we don't have strings. So we know we have to add a case for this, a string, and it holds a string. All right. And I guess it probably does not need to hold the quote marks around it, just the string itself. I don't think this breaks anything. I don't think we have a case statement that depends on this. Okay. All right. So let's do Lexer tests. Tested end. Integer line number. Or more. I think this is closer to integer. You know, it's kind of. Oh, that's the line number. Okay, numbers. Do we have some stuff around numbers? Yeah. Yeah, I think this goes maybe after the numbers. Okay, so test. I don't know. String knows its contents would be progress. Okay, I hope the background noise is eased off a little. Okay. Let's see. Can we... I think we can just do a check token. Okay, so we need quotes and body and more quotes. That should be a string with body. Okay, I don't think these basics, I don't think they do the deal where you double quote. They don't do the C style like this. I don't think they do the double quote deal. So I'm not sure there's a way to put a quote mark in a string unless you use those string functions. You could, well, I don't even see anything to append strings. Okay, that's really odd. I'm curious. Maybe there is no way to do that. Okay, but I don't think there's anything with quotes. We can go through the documents later, but this is going to fail. Nobody produces this string token for anything. Okay, not yet implemented. Yeah. And Lexer, well, it's fine. Not yet. All right. So the Lexer, it looks for all these starting characters, but we don't have a case for the quote mark. Okay, so let's see. I guess after the numbers again is probably fine. Case double quote. And let's do return string. And we'll put that after the numbers. Okay. Func string returns a token. Okay. Does that fit? I guess these all return question marks. Yeah, although that's probably not necessary. Okay, this should fail the same way. Actually, we'll get a different error. Okay. String NYI. Okay, so we're down in our new code. All right. So where do we go? Okay, so we're in here. We've seen the quote mark, so we got to skip past that. All right, and then I think we have an until. Ignore until. Well, I think I did this with the names too. Let's capture the start index. Is index. Okay. No, I don't think we need to do that. Let's let body equal nothing so far. Okay. So while program subindex is not a double quote, we're going to add that character to the body. Maybe I have to say string, if I recall. And increment index. Body is a let. Oh, I meant to say var. Okay, instead of val. Okay, so we add the characters in, and at the end we know it is that character, a double quote. So we skip over that. and then we're going to return a string with the body. Okay, so start empty, skip over the quote mark, read until we find a quote mark, and accumulate those as we do. Skip over that last quote mark, and we got a body, and our next character is the one after the quote mark, so we're in good shape. I think that passes. All right. Now, I don't know if you've ever done this, but unterminated string is an error. And we have a check error? No. How do we check for errors? Oh, I guess it's an error like that. Okay. So we'll check token body, and we expect an error unterminated string. Okay. And that's gonna fail probably with an infinite loop. Oh, out of bounds. Oh, okay. Yeah, that makes sense too. All right, because we keep incrementing while it's not a quote mark. Well, there is no quote mark at the end, so it's going to keep incrementing until it just gets past the end of the whole string. So we really have to watch for our new lines as well. Okay, so while program is not that, and program subindex is not new line, then do that. Okay, if we get out, and I guess basically we're requiring, do we have to require? We really expect to see a double quote, or otherwise it's an error. I don't think we gave ourselves a helper for this. We did in the parser. Yeah. Okay, so if program subindex not equal new line, well, maybe I should say if it equals new line, then we're going to return an error, unterminated string. Okay, and if it is, if it's not a new line, it must be a quote mark, so we continue down this path. And here we're not skipping over the new line because we know every statement has to terminate with 1, so eventually we'll get to it. It's okay. All right. I think those tests should pass now. Okay. And now the silliness, I guess you could say, let's find our test again. There we go. Strings. Okay. Test strings may contain blanks. I need a back quote. Hello world should be a string. Hello world. And formatting drives me crazy. Why aren't you at the same column? Okay, I think. All right, that looks better. And we'll run lecture tests. And I expect it to be hello world with no spaces. Hello world with no spaces. Okay. Ah, boy. It's this normalizing thing. Excuse me. All right. So this self.program equals program replacing occurrences of, let's just say, well, can I do this? I don't know if it's, I'm surprised it doesn't complain. I never quite know when it's going to decide. It's, yeah, self-used and normalized before all methods. I think I can make this static. Is that going to solve it? Because I'm not referencing this program. Oh. Okay. This should be the same. Now what we want to do is, oh, yeah, the hello world one. Okay, what we want to do is we got to be more sophisticated, right? We can't just replace every space. We got to pay attention. If the space is between quote marks, then it's not replaced. So I think what we can do, this is nothing that you could never get by with this in the old days on the the machines you were running in the 1980s that ran these old basics. But what I can do is I can split on quote and then keep track of which one is even and odd and put the pieces back together. Yeah, let's try that. And I think I'll read the documentation just for variety, or at least an example. I think I can get, okay, I think there's a way to get the spaces, yeah, omitting sequences. I think you can get the separators in there. If oh, empties, no. Well, I guess I know them now. Right. So if I know it's broken up by them, I think I can do something with it. Okay. So if I oh, this is obnoxious in a way. The pieces are program.split back quote. Okay. So now we know a valid program can't start with one of these quote marks. This is separator or something like that. Program is a string. It was separated by separator. Okay. The first character can't be a quote. It's got to be a line number. So we're going to assume it's it's not. All right. So the first piece, anything up to the first quote mark, we want to squeeze. And anything after, the next one, we want to insert a quote and this thing with spaces and then another quote. Okay. Oh, yay. So I could theoretically iterate through pieces. I don't know. Can I do that? I want to find one of those nice functional pipelines because it feels like that should just work. But if I don't, I can at least build up a giant string that's going to hold it and go that way. Yeah, there's an iterator that what is it? It gives you the index and the value. Enumerated sequence of pairs nx. Yeah, so we get an integer and, well, x is going to be the string. Probably a subsequence, so we'll have to fiddle with that. Okay, but we can do enumerated. And it's n comma piece n. Okay. And then if n mod 2 is 0, then it's an even piece, like 0. Okay. If it equals 0, then we're going to return the piece, replacing the parts. Okay. So this thing. Squeeze out the spaces on the even pieces, and on the odd pieces, we just return them. Okay. And then enumerated gives you the stream, and then map end piece. Okay, so we map piece is a substring, so we're going to have to make it into a string. Piece and a string piece for consistency. Ugh, 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 breaking. All right, but we have a list of these things, and then I think we can just this is quote. I don't know. I guess we'll get it right and then we'll deal with it. Okay, so even pieces, we squeeze out the spaces. Odd pieces, we put the quote marks back in and append the piece together. And then the whole thing, we reduce into no, we just joined. Okay, is that legit? Okay. let normalized pieces equal pieces dot that, and then we'll return normalized pieces plus new line. Okay. I feel like I'm doing more than I should, maybe. I don't know, but this test should pass now, I hope. If not, I'm probably way off base. My computer just went into fan mode for some reason. I don't think there's anything running that should do that. All right. Well, we've been at it an hour. I think I can probably go till an hour more. Catch up a little time anyway there. And we'll just take a break, a 3-minute break, and hopefully the build will be done by then. All right. So I'll see you in a couple of minutes. All right. Welcome back. Basically, the compiler got balled up and said this expression was too complicated for it. So I just moved the join down here. And I think that built. Okay, so let's run Parser tests. Now that shouldn't be particularly slow, although I restarted Xcode, so I take that back. Well, while we're thinking about this, the other bit of normalization is the old basics were, well, I think the oldest ones were case, mono case. Right, everything in this, like somewhere they had a picture of their teletype. I don't even know if it has a shift key. Let's find that. There it is. Oh, there is a shift key. So apparently you can do lowercase letters, but at least the tradition is it's treated as all uppercase. All right, and so we can also do the piece to check. Oh my. Okay, string knows its content. Oh, well, that's clearly. Is that clearly anything? Undetermined string is an error. What was the error you got? Not yet implemented. Now, let's see what check token does. I'm not 100% sure. Oh. We're going to have to do something like this. Yeah, let's change this to check string. Making up a new method. Because you just really cannot have those at the beginning. Okay, so where's check token? Well, it's not a program. It's a entity item of string and the expected token. All right, and then we're doing kind of, where's that 1110 print thing? We're doing this basically. Okay, so this, and it should become item. Okay, I think we've already checked this, so we're just skipping ahead. And token equals expected. Okay, we'll run the Lexer test again. Okay, just one, all right. Unterminated string, and we got string body. Can we tell? So we would split this into two parts, right? So we would have had 25 print, quote, something, and no end quote. So we'd get part 0, part 1. And that would insert the quotes at the end. But I guess if we ended up in the middle of a string, that's an error. Okay. Where's Lexer? Well, I think it. We've inserted the quote back at the end of things. Is that going to be a problem? Oh, I just don't know. Oh. How do we want to deal with that? So right now that quoted string could be going on for 5 lines, right? And the whole rest of that program would be stuck in there. And yet, I don't know, when we hit the new line, I'm sorry, what was our body? We found body. Well, now it wouldn't show up right away. Yeah, let's check one more token, I think. Right, that should be equaled. And if we do token equals lexer.next, we should get a new line. Now, will we? I guess it would put it back. It would slap the new line on the bottom. I don't know a good way to do this then. I guess we know if the number of pieces is even. So we have 0 and 1. 0 is the front of the line. 1 is the string. Then there's an error. Do we report it there? Well, maybe we need to. But it won't matter. Yeah, this is where I don't know if I'm being too clever. And it's taking me too long to do it too, so there's some sort of smaller byte I need to find. So the problem is we're inserting new lines that may not have existed. And if the original, can we tell the end? I don't want to count them again. Oh, golly. What's another way to do this? Another way would be write a little state machine that just moves forward it seems like this is better, except that we have this error. And it won't be unterminated because we just terminated it right there. And if it were valid, it would always end with that quote. It's really if any of the odd pieces contain new lines, then we have a problem. And why won't it find that? I guess that's the last one that's giving us the problem here, right? So if it happened in the middle, yeah, so, okay, oh boy. If the quote mark happened in the middle of a line and we finished out the line, this code in 79 inserts the final quote mark. Now, if it were the middle line of the program, it would insert the final quote mark after the new lines, right? Yeah, so I think maybe let me try this. I think maybe I need to put my new line at the beginning and not at the end. Okay, so this piece comes off. What does that do? Okay, let's run. I don't think I'm valued. My speculations are not helping. Okay. But now I do think this will guarantee there's a new line in the last piece if program plus new line. Wait, don't you program? Okay, is that going to be okay? What's your type? Oh, come on, wake up. Let's do build. Program 2 is string. Okay, that's what I expect. All right. Now, Lexer. Okay. It's non-obvious. I'm not sure you can consider this obvious to start with, but we're definitely putting this in as a sentinel to make sure every line is terminated. Because some systems, if the last line of a, if you're editing the thing, do you have a final new line or not? Okay. Even in here, like in the editor, notice, oh no, it used to be grayed out. I don't know why they're all grayed out now. Okay, the line you're on, oops. The line you're on is not gray. Okay. Okay, well. So with this way, the last piece has a new line. And so you end up with this opening quote, some stuff, a new line, more stuff, and a final quote. But you'll definitely get an error with the new line in the string. So I think that's why we're looking good. And let me do one more thing with the normalization. Let's find, like, right. Let's make sure it's uppercased. And let's make sure our string is mixed case. Body, so well, let's do this. Hello world. Hello world. Okay, mixed case. String should be fine, all right. And the reason I'm worrying about this is I want to make sure that non-strings are uppercased. Okay, so if I check token print, I expect print. Okay, yeah, that one's easy, but if I do print lowercase or mixed case, it should work. It will not, but we want it to. Okay, and it better be, not yet implemented. We don't know what that token is because we saw a lowercase letter and we don't handle them. All right, but I don't want to ever see a lowercase letter at the top level. Okay, so what I want to do is once you've replaced these occurrences, I want to go to uppercase. Oh, come on, you got to have a to upper. Dot uppercased. Okay. I want to non-strings get uppercased. All right. Okay, so now we have we parse string constants, taking care not to squeeze out spaces, and we uppercase non-string text. Okay. Getting there again. That's still it's a heck of a piece of code. That's not a compliment. All right. So we're in the process of adding strings. Let's deal with them on the parser level. All right. And string expressions, and go down to our grammar. Well, the reality is strings are legal expressions, and you can do stuff with them. You can do or and negation, and you can do relational operators. You can't do plus, times, powers, minus, but they should be acceptable as a factor. Excuse me. Okay, so before we do functions, let's do strings. Factor goes to string. Okay, and then at some point we're going to have to do some enforcing. Okay, and that's why we have all these types, so we can enforce it. I also don't know, we may want to split up in our interpreter. Well, let's look at parse. We return, well, these op1s have the tokens. It's like, should the operator, I mean, maybe they should distinguish strings versus string ops versus numeric ops. And I don't know what will happen there. We'll have to see what we need. All right, but the parser. Okay, so let's let's say we assign $1 equals some string. That should seem fine. Okay. Let's see. A test. When in doubt. Test standalone string in expression. All right, now this should be legal. Yeah, so let's do like $25 equals quote something. And actually that whole thing is probably kind of what we want. Okay, so I don't need to let $1 equals quote string. Back quote string back quote. Okay, 25. $1 equals string in quotes. Okay. The parser should like that. 25 assign variable $1 of type string should be the string just the inside. Let's do body. Okay. Standalone string and expression. Type expression has no member string. Expression. Well, that's sure enough true. Number, variable. I would say string is even more primitive than variable. String of string. Okay. And okay. And I think we'll make it so our test doesn't mind. All right. To add missing cases. Oh, interpreter. Oh, interesting. Evaluate. Let's return -1. Something's going on there. Non-void should return a function. Switch must be exhaustive. Okay. Backdoor test. Okay, skip is not equal, and the error is Expected start of expression. Okay. Let's find expected start. Expected start of expression. Oh, well, okay. This is a print. Okay, well, no, we'll want that. And factor. Okay, that's probably the right thing. So, yeah, I said I wanted it after numbers. Else if case dot string of let text equal token. Return string of token. Okay. And then we'll have to watch our prints. We'll want to add a test case for that one. But let's get this working and then we'll move on. Build failed. Cannot convert token. Text. Okay, still messed up. Now, extra characters at end line. Extra characters at end of line. So we've missed a equals body quote. All right, so the extra characters at end of line, it says that's from not having a new line at the end of a line. I don't want interpreter, I want parser. Okay, so if our statement, oh, did we not consume our token? It's so easy to make the mistake. Okay, string text equals token return string. Yeah, we need to do a next token. If we go in numeric factor, well, or variable, right? We're going to take the next token. Same thing, numeric factor. We got to take the next token. So, okay. And oh, Lexer test should be fine, but we care about parser test. Yeah, now that's good. All right, and then we said the same thing. The print, we got to worry about that. Okay. Print string. And let's do that. Print body. This should be a print. The expression is string body. And that's an array. How's my parens? That's a line. That's that. No, I still got too many. Okay. Print takes an expression. Oh, body. Too many. Okay. Parser tests. Right. Skip and the messages. Express to start of expression. All right. And we know our print statements. Oh. Okay. So we got to find our print. Print statement. Okay, number variable. Well, number, we also want to allow string. Okay. And parser tests, string of anything. Okay. So we allow a string as a factor in expressions and can print it. That's only from the parsing perspective. Okay. All right. Now, this is where I'm not so sure where to go from here. Let's get down to our factor. So you got a string, and we don't want to allow negation of strings. It doesn't mean anything to us. And same thing for exponents. Like if there's an exponent, it really doesn't mean anything. I don't. Now, this is okay. We can go straight to factor. And I guess somewhere here, we're going to have to, before we create the op2, we want to check the type match. Okay. And only if left and right are both numeric does this make sense. I mean, you could define string to the third to mean string, string, string. I think Python maybe does that. Maybe JavaScript too. I can't remember, but it could be given meaning, but it's not in BASIC. All right. So I think what we want to say is the result of a minus cannot be a string, regardless of whatever types it comes up with. Okay, so we're going to have a bunch of type checking stuff, and this is, we could just accept it and like whatever, don't do that. Whatever junk happens is what happens. But I don't think we want to work that way. So I don't know, these check errors, that's probably what we want. More check error tests. Okay, so, and there's going to be a bunch of them. So string can't do unary minus. String can't do arithmetic operations. How's that? String can't do arithmetic. Okay, that seems good. So we got a check error kind of thing. Let's find one. And I'm just going to put them all in one place. A equals minus B dollar is a maybe it's just a type mismatch. I think that's probably good enough. We'll at some point worry about how to actually point these things out and all that stuff. But I think for our purposes here, this is a type mismatch. That's a good thing. And I think we can kind of fit them on one line. Almost. If I broaden this a little. Okay. And I'm just going to put a bunch. Okay, A equals B dollar to the 3. Or 3 to the B dollar. And maybe we can put a blank here for each one of these. Next one up is plus times and divide. No, we'll do times first. Okay, and then plus and minus, I think. Plus and minus. Now, relational operators are allowed, okay, and logical operators are allowed. Okay, so these should be type mismatch errors. Excuse me. All right, and nothing enforces that. Okay, so let's get down to the minus unary again. Yeah. Okay, next token, try power. Okay. I guess if value.type is not float, then throw type mismatch. Okay, so we're enforcing it there. Okay, so this one should pass, but the next one should fail. All right, no problem. Now this one, let's say, okay, if left dot type is not float, or right dot type is not float, same deal. Okay. And the next one should, both the next two should pass. Right, okay. Let's extract this out. We got left and right. Everything else can be in there. Require float types on left and right. I think that's what we're doing. These operators, okay, and left and right. If the let type is not float or the right type is not float, it's an error. Okay. And then I think we've got the same logic here. I did. Okay. And same here. Okay, and I'm going to move this up. I don't know. It's not a good place to put it. Okay, it's certainly not part of that. Okay. Yeah. Let's see how we do. Okay. I think we need to next we need to make sure that these well, okay. I think we need to make sure our relationals match each other. They can both be strings or both be ints. That's either one is fine, but they can't differ. Okay. Borrow that. Okay. Test relational operator needs same types. Okay. $B less than 3. Okay, should be a type mismatch. Are these, well, they're all kind of the same. Let's do another one. Let's see, $B equal, let's do 3 equals $B. 33 equals $B. Okay. Those should be a type mismatch. But I guess we'll need it. Okay, these will fail. Okay, so we're not requiring float types. I think we want to make a different one that's similar. Require matching types. If left.type not equal right.type, then we got a mismatch. Okay. Get to our relops and negate relational. Okay, so here we're doing left and right. Oops. Nope. Require matching types, left, right. Okay. And of course I want to try. Okay, and then negation does not make sense on a string. Okay, so I think we should do, let's find that -1. This should be require float type of value. If the expression type is not float, then there's a type mismatch. Okay. And we'll want that here. Let's get this one as a check error. I guess too fast. Okay. And or and not. Okay, and then I mean, you could say $A less than B dollar and C dollar less than D dollar, but the less than operator produces a number. So these things are in the require numeric kind of point of view. So let's get those in there. All right, those should, well, they'll fail at this point. Okay, so there's and there's or, and then we're at the top. Okay, so I think we got them all. All right. So basically at this point we've done the type enforcement all the way up the tree. What happens on the interpreter side, that's still not determined. And I think that's where we'll pick up next time. So we have parse trees, the legal ones, you know, can have expressions in them. So you could say $a less than $a, and it should do the right thing, compare dictionary order kind of thing. But right now, I mean, this is just kind of a peek ahead. Our evaluation returns float every time and doesn't know what to do about strings. Okay, so even when we have operators that are legal, like less than, then it's just not clear what to do. So we need to make. I think this is the point where we need to make our values either make our values more general or split up numerical evaluation from the other. But I think it's really more general values, because you can mix and match these things because of these little functions, right? So we could, let's see, ASC turns it into an integer. So ASC of some expression with a string is of type integer, and it's or float, and it's fine to work with the floats. So the strings, I think everybody has to deal with it. And I think that means we're going to have to make values that could be strings or numbers or arrays and so on. So we will pick up there. Tomorrow I'll be back to my normal time, 9 to 11:30 Central, 10 to 12:30 Eastern, and 3 to 5:30 UTC. And I hope you have a good evening. And we made some progress today. I'm happy about that. But we'll get these things working fully tomorrow and have some strings to show for it. All right, so take care. See you.